This is a production of Cornell University.
Thanks, Dave. Donnie, Peter, Woodbury, and I are just researchers. And I want to just say thanks to Dave Wolf and Ag and Markets for supporting this so that just the researchers, just the farmers, just the policymakers, just the educators can meet in a room together and come up with a just plan. And you know, climate change, I've been doing it for a while, and I went through a period of despair. And I no longer have that sense of despair because it is one gigantic puzzle, and it's providing us an opportunity to join forces because soil health, water quality, and air quality are all connected to our great lunches that we eat on a day like today. So the arrow, okay. So just to frame the talk for how farms, landowners, and citizens can promote resiliency through the soil, I'm going to give you one example, right? With climate change, we have a longer growing season, so we have an opportunity for double cropping, which increases the sequestration and slows the rate of climate change. It increases the resiliency by reducing erosion. It reduces the impact from extreme weather events by being able to absorb extreme precipitation, and it increases productivity because you are working to crops, which results in local and global sustainability, increasing knowledge, and maximizing impacts for future generations, right? This is a puzzle, and we can see. So just to give some context, Cuomo has an executive order 166, which has a goal of 40 by 30, which is a 40% reduction in 1990 levels of greenhouse gases by 2030, and 80 by 50. So that's an 80% reduction by 2050, and this is for all sectors, right? This is a huge group effort. And there's tons of programs that there are out there to support these agendas. And if you haven't seen some of these names, look for them because there are opportunities for all of us in there. Now, when we talk about greenhouse gases, most people think about CO2 because indeed, most of our greenhouse gases come from CO2. That's the big piece of that pie. But two smaller pieces are methane and nitrous oxide. And the reason I say this is because in agriculture, we need to think beyond carbon dioxide. We must also consider methane and nitrous oxide. Today, I will be talking a little bit about nitrous oxide related to nitrogen fertilizer in the soil, but methane applies to other ag practices. So the reason why it's important to talk about these other greenhouse gases is that they have different global warming potentials. And these different gases have different impacts on the Earth's warming. And in order to compare them or think about them, we have this equation. So if CO2 by definition has a global warming potential of 1, what you need to notice is that nitrous oxide is 300 times more potent of a greenhouse gas than CO2. My point being here is managing nitrogen on your field is incredibly important, right? Because it has that factorial. So how do we avoid emitting greenhouse gases? Some examples involving carbon dioxide and nitrous oxide. Well, we can avoid producing carbon-based greenhouse gases. We reduce tractor passes, we reduce tillage, we reduce synthetic nitrogen purchase, right? Synthetic nitrogen is a really energy-intensive process. So you're reducing the fuel used at that stage. Or you can avoid the greenhouse gas impact from nitrogen processes. So you reduce your synthetic nitrogen use to reduce the field nitrous oxide emissions, and you manage your manure to also reduce your field nitrous oxide emissions. Some ways that we can mitigate or reduce greenhouse gases with the soil is sequestering the carbon dioxide in soils, in food products or other products, root systems, wood or wood products. We can do this through promoting vegetative cover, perennials, cover crops, improve pasture and grazing, add biochars or other amendments to soil, increase yield by double cropping, plant rows of trees, buffer strips, and reforest marginal lands, and manage your wood lots to increase the carbon in both the trees and in the soil. One of the important things, though, when thinking about carbon sequestration, particularly with soils, is this concept of permanence. For carbon sequestration to have a meaningful impact on the atmosphere, it's necessary to ensure that the carbon remains sequestered and is not released to the atmosphere. So years of carbon built up in soils can be released back to the atmosphere in a very short period of time. So the point here is some strategies are permanent and others are not so much. But all of the soil health strategies we've been talking about today are important for productivity, right? So some things are better applicable to mitigating climate change and others are better for productivity, right? So just to summarize, conserve or improve vegetative cover. So we can protect agriculture and forest lands from development. Defense. We move towards soil sequestration mechanisms, including perennials, double crops, cover crops, reduce tillage, biochar, and improve pasture and grazing. And why do we do that? These practices sequester carbon. They improve productivity, they reduce erosion, improve water quality, and improve soil health. Improve nutrient management. We reduce the synthetic nitrogen consumption to reduce the upstream emissions from producing that. And this is both for agricultural lands, but also for landscapers, right? Yards. Manage manure and synthetic nitrogen on the field to reduce field nitrous oxide emissions. Why do we do this? They remove emissions from fertilizer manufacturing, they improve profitability, they improve water quality, improve air quality, and improve soil health. Improve forest management. So more than 60% of our state soil is forested, and 30% is on ag land. 30% of ag land is wooded. So farms can manage their woodlots. Why these practices sequester carbon in tree trunks, soil, profitable, long-lived wood products, reduce erosion, improve water quality, air quality, and soil. So, improve soil health reduces greenhouse gases. So as farms increase soil carbon, that increases the soil health, the crop productivity, the water infiltration and retention, and can also sequester carbon in the soil and in the products that we pull off the field. These mechanisms include tillage practices, soil amendments, annual versus perennial crops, cover crops, double crops, and forests on marginal lands. Now, how do we do it? I'm just going to say that there are lots of opportunities out there, and we need to start leveraging these opportunities for these multiple benefits. So there are climate smart community grants that are due July 27th for municipalities. And the projects include, but are not limited to, reduction of future flood risks or implementation of municipal food waste and composting programs, right? So there's some work there. There's trees for tributaries. This is an application that's due in September for planting trees along waterways as buffer strips for nutrient benefit, but also it has a climate change mitigating benefit. In February of 2018 and possibly in February of 2019, the Climate Resilient Farming allocates $2 million available, and it covers 75% of the costs. And this money is for agricultural waste storage cover and flare systems, riparian buffer systems, stream corridor, erosion control, rotational grazing, and soil conservation systems. And on the horizon, the Climate Action Reserve, which is a carbon trading reserve, is revising their nitrogen management credits. And those should be coming out soon as another way to fund nitrogen management on your acreage. Future needs, we need assessments to better quantify the financial, environmental benefits and costs. We need to promote the best management practices that we're already doing, that also include greenhouse gas mitigation for climate change adaptation and long-term resiliency. And we need to create some policies to provide science-based information to policymakers as they negotiate a multitude of societal needs. And I guess what I would like to do is open it up for questions or comments, particularly on how we can think about taking climate change into the next generation of our work.
This has been a production of Cornell University, on the web at cornell.edu.